Hi everyone, welcome to Geometry. We're going to go over lesson 2-4 today. All right, this is page 92. Lesson 2-4 is about slopes of parallel and perpendicular lines. By the end of this lesson, you should be able to use a slope to solve problems about parallel and perpendicular lines. Let's look at model and discuss question. Pillar and Jake begin climbing to the top of a 100-feet monument at the same time along two different sets of steps at the same rate. The tables show their distances above ground level after a number of steps. So if you look at the diagram, you see that Pillar is 1.5 feet above ground level, which is over here, and that's 0 feet. And Jake began climbing from 4.5 feet above the ground level. And this is the table we have. After one step, Pillar is at 2 feet above ground, Jake is at 5 feet above ground, and so on. So after 25th step, Pillar is on 14 feet. After 29th step, Jake is at 19 feet above the ground. So part A. How many feet does each student climb after 10 steps? It's not shown in the table, but can you figure that out? Do you see the pattern? First, you need to be able to identify, is there going to be a pattern? Yes, because why? Because they have the same rate. If they have the same rate, that means they have a pattern that goes with the number of increasing height, right? So after 10 steps, you're going to figure out what the rate is for Pillar and Jake and see where they are at above ground level. Think about it. Okay, do you have an idea? Well, first of all, what do you understand from the phrase at the same rate? At the same rate tells you the important information that each person takes the same number of steps in the same amount of time. If you look at the first step they took, Pillar is at 2 feet, Jake is at 5 feet, and look where they started from, 1.5 and 4.5. So one step for each of them would be equivalent to half feet, right? And that makes sense because the stairs should be the same height for both of them. So if we talk about 10 steps, it's half feet times 10. And so that's going to be 5 feet. Let's see. Half feet times 10 is equal to 5 feet. So if you add that to the original feet, that's where you're at feet above the ground level for each one. But the question is, how many feet does each student climb after 10 steps? They're both going to climb 5 feet in 10 steps. Okay, so let's write that down. They will climb 10 feet, or wait, 10 steps, right? So 5 feet after 10 steps. Explain, because they each climb half feet per step. So half times 10 is equal to 5. Part B. Will Pillar and Jake be at the same height after the same number of steps? Oh, you might already have an answer immediately, right? So first of all, is the information about the height where the two people start climbing important? Yes, you need to start you need to start thinking about where they started climbing from, right? Pillar started at 1.5 feet and Jake started at 4.5 feet. So each step they take is going to be the same because all the stairs have the same height, but that means they're not going to be at the same height after the same number of steps because in the beginning, they weren't starting at the same level, right? So the answer is no, they will not. Okay. Jake started higher than Pillar did. And since they both climb together at the same speed, both climb at the same rate, Jake will reach the top first, according to the steps, if they are taking the same steps at the same time, right? Part C, what would you expect the graphs of each to look like given your answers to parts A and B? So if you plot those points, it's going to show the pattern. What would you expect to see the pattern on the graph? Okay, so if you graph the line for Pillar, right? You start with 1 step 2. And then Jake starts at 1, 2, 3, 4, 5. And then they go up at the same rate. So they're going to start differently at a different level, but their slope is going to be the same, which means the lines are never going to meet each other, right? They are parallel. They're parallel lines. So you can expect the graphs to look like to be 2 parallel lines for Pillar and Jake. Let's write that down. The 2 graphs will be parallel lines with slope of how many feet per step is going to be your slope, right? Which is half feet. Let's not write the feet. Half. Okay. But Pillar's y-intercept is where the step is 0, where they started with, right? It's 1.5 feet. And Jake's is 4.5 feet. Okay? All right, so in this lesson, let's keep thinking about these questions. How do the slopes of lines that are parallel to each other compare? How do the slopes of lines that are perpendicular to each other compare? Okay. we're going to look at the characteristics of parallel lines and perpendicular lines. All right, let's look at the first example, slopes of parallel lines. A hill and a gondola line 20 feet above the ground that goes up the hill both have slope 1/2. What is the geometric relationship between the hill and the gondola line? Okay, first we could model the hill and gondola line on a coordinate plane where x represents the horizontal distance from the base of the hill and y represents the vertical distance from the base of the hill. Okay, they're both going to represent distances. So you have a gondola in the graph here, and the horizontal distance where it's hanging is going to be where you're starting from. That is your y-intercept, right? Because the line intercepts the y-axis. Y-intercept of the hill, though, is going to be 0 at 0, and then it starts going up. So the hill is also rising while gondola is also rising parallel to the hill, right? So the equation of the gondola line is given, y equals 1/2 x plus 20. The equation of the hill is y equals 1/2 x. And if you notice, their slopes are the same, which means they have a constant rate that are the same. They increase the same amount of horizontal distance per vertical distance. So the lines are parallel, right? Because both of the slopes are 1/2, it means every foot is increased for every 2 feet of horizontal distance, right? That is what this means, to rise over run. Rise describes your up and down movement. Run describes your left and right movement. That's vertical versus horizontal, okay? So it never gets any closer or any further away, which is the characteristic of two parallel lines. So you can make a conjecture. If two linear equations have the same slope, then the graphs of the equations are parallel. Okay, that is one characteristic of two parallel lines. So let's try number 1. Suppose another line for a chairlift is placed at a constant distance c below the gondola line. Okay, what is an equation of the new line? Is the new line also parallel to the hill? Right? It says it's still at a constant distance, right? Below the gondola line. So it needs to be below the gondola line, but it's still gonna be the same slope, right? So it could be anywhere below the gondola line, just not too close to the ground, I guess. Right? So you can say, what you can say is that you have the same slope, but it's going to be, the y-intercept is going to be below 20. And it's understood that it's going to be above 0, right? So yes, you can theoretically write an equation with your variables. So what is an equation of the new line? You don't have to have an exact number in this case. So you can say, oh, it could be y equals the 1/2, that's your slope, x, plus, let's say b, where b is less than 20, because b is your y-intercept, and greater than 0. Okay. Is the new line also parallel to the hill? Yes. Because why? Because they have the same slope. Okay. Let's look at theorem 2-13. Two non-vertical lines are parallel if and only if their slopes are equal. Any two vertical lines are parallel. If you see the word if and only if, that means you can go either way. Like your converse would be true. Okay, so if their slopes are equal, that means two vertical lines are parallel. Okay, it could go both ways. So any two vertical lines are going to be parallel because they're vertical, right? And any two horizontal lines are parallel too. So let's look at some examples. If P and Q are both not vertical, they need to have the same slope to prove that is a parallel line. If P and Q are both vertical, then they already have the same slope, right? Then they're parallel. So the key is that the two lines have the same slope. All right, let's look at example 2. Check parallelism. Our lines K and N parallel. So what are our lines K and L? K and L over here, right? They look like parallel lines, but are they really? There could be numerous lines that could look like they're parallel, but their slopes don't actually really exactly equal to each other, right? Just like, you know, numbers, there are a lot of numbers that are very close to each other, but are they really equal to each other? So for example, 0.00001 and 0, are they really equal to each other? Well, they're really close, but they're not the same thing, right? So you always have to check the slope of the line to say that they are parallel or non-parallel. So step 1, find the slope of line K, and then step 2, find the slope of line N, compare the slopes, and if they're equal to each other, they are parallel. So let's count the slope of line K. So there are two ways to find the slope of the line. Count them on the graph, if you have a graph. Secondly, you have a slope equation, rise over run. So change in y over change in x. So the change in the vertical distance versus the change in the horizontal distance would be your equation. So if you have 2 points that you can pick out from the line, you can subtract the y values over the difference of the x values would be your slope of the line. So in this example, they picked -2, 2 and 2, -3 because those points look like they fall exactly between the intersection of the grid, right? So it looks pretty exact. So if you count those, count the slope, you have to count the vertical distance first. So 1, 2, 3, 4, 5. We're going down 5, and you go right 1, 2, 3, 4 blocks, right? So that's going to be -5 over 4, or you can use this slope equation. Okay, same thing for line N. We're going to choose 1, 2 and 4, -2. We're going 1, 2, 3, 4 down, and 1, 2, 3 right. Right? So we have -4 over 3. All right. So then compare them. Is -5 over 4 equal to -4 over 3? They're very similar. They're very close to each other, but they're not the same number. So lines K and N are not parallel. They're going to meet at some point if you keep going. Okay, let's look at number 2. Our lines M and Q parallel, right? I want you to solve this first and come back when you're ready. All right, first, let's check answers. First, you need to find the slopes of M and Q, right? You can count them or you can use the equation of the slope. So first, you're gonna pick a point. What's a good point for line M? We have -4, 3. And we have, is that a good point? Yes. -1, 4. Okay. So you're going to subtract the y values, 4 minus 3. And if you started with this point, you have to start with that point on the bottom as well for the x values. So -1 minus -4 is +4, right? So that's 1 over 3. That is your slope for M. What about Q? Pick a point. That could be our point. -4, -2. And another point. 1, 0. Okay. So -2 minus 0, -4 minus 1 is going to be -2 over -5. That's 2 over 5. Are they equal to each other? No, 1 over 3 is not equal to 2 over 5. So yeah, the answer is no. They are not parallel. Okay. Let's look at the next page. Theorem 2-14. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Okay. A vertical line and a horizontal line are perpendicular to each other. So first of all, we know that for parallel lines, the slopes are going to be the same. For perpendicular lines, though, their slopes needs to have a product of -1. What does that mean? If you multiply the slopes of two lines, your answer has to be -1. Okay? Product of their slopes, not that their slopes need to be -1, or else, right, their slopes are the same and they're going to be parallel. And also, a vertical line and a horizontal line are perpendicular to each other. All right, look at an example. If P and Q are both not vertical, then the slopes has to have a product of -1. So for example, you have a slope of 1 and a slope of -1. If you multiply them, do you get a -1? Yes. Then that would be a perpendicular line. Make sense? And if P and Q are vertical and horizontal, they are automatically perpendicular lines. Okay, let's look at example 3. Check perpendicularity. Are lines J and K perpendicular? So also for checking perpendicularity, you need to figure out the slope first. All right, so pick 2 points for a line and find the slope for J, and pick another 2 points for K, find the slope for K. Okay, the process of finding the slope is the same. You just need to compare the numbers and figure out if it's parallel or perpendicular. Okay, so I'm going to skip steps 1 and 2. Look for 2 points on each line where you can easily read the coordinates of the points on the graph. Okay, so then you have slopes -3 over 2 and 2 over 3. Let's check. Well, they're not going to be parallel, right? Obviously, they're not the same number, but for checking for perpendicularity, you're going to multiply the slopes. Okay, if you multiply -3 over 2 and 2 over 3, you get -1. And is that what you're looking for perpendicularity? Yes, if the product of two slopes is equal to -1, they are perpendicular. So you can say, you can justify your reasoning by showing that the product of their slopes is equal to -1. Okay, let's check triad number 3, A and B. Are lines H and L perpendicular? All right, so pick 2 points for H and L. We're gonna pick one line H for line H. We're gonna pick 1, -3. And what's another good point? Okay, is that gonna be a point? Is that too far? Let's do -5, 1. Okay. And then your slope is going to be 1 plus 3, because 1 minus -3 is 1 plus 3. And -5 minus 1. So 4 over -6. Okay. -2 over 3. All right. And what about L? Okay, let's pick this one and the same point over here. 1, -3 and 3, 2. Okay, so your slope for line L is going to be -3 minus 2. I'm going to start with the first point, and then 1 minus 3. It doesn't matter which point you start with, start subtracting from. You just have to be consistent about it. Okay, -5 over -2. That's going to be 5 over 2. If you multiply those two, do you get -1? No. -5 over 3 is not -1. So your answer is no. Like H and L are not perpendicular. And if you look at H and L, visually it does not look exactly perpendicular either, right? That's not gonna be a perfectly 90 degrees. But you should always back up your reasoning with algebra reasoning, okay? What about K and M? K and M, okay? We already know that the slope of K is 2 over 3, right? And M, have we figured that out yet? No. So let's figure the slope of M out. Pick 2 lines. 2, -5. Okay. 2, -5. And let's pick this one. 0, 3. Okay. So the slope should be, I'm going to start with the second point now. 3 minus -5 is +5. 0 minus 2. Okay. And then you have 8 over -2, which is -4. Is -4 times 2 over 3 going to be -1? No, that is not -1. So no. No for both. They are both, the pairs are both not perpendicular. Okay, that was example 3 triads. Let's look at the last example, example 4. Write equations of parallel and perpendicular lines. Okay, part A. What is an equation of the line through P that is parallel to L? Now we are given one line and a point P that, and our task is to write a parallel line that goes through point P. And there is one exactly one line that's parallel to line L that goes through point P, right? That was the theorem we learned last lesson. Okay, step 1, identify the slope of the parallel line. We look at the slope-intercept form of line L. That is our slope. It's easy to find. Okay, and the parallel lines have equal slopes, so your new equation of the line will have the slope of 1/2. And so your y-intercept form is y equals mx plus b, and we're gonna one by one fill in the information. We have the slope now. We just need the y-intercept to finish writing the equation of the line, right? So you're gonna use any point, but we're only given 1 point, right? So we're gonna use the point 4, 1. Any point on the line is possible, but we're just given 1 point, okay? So plug in 4 for x, plug in 1 for y, because if you plug in any point into an equation of the line, you should have an equation that makes sense, right? If you plug in x, you should get the y value that corresponds to that x value, which is the coordinate point x comma y. That is the pair. Okay, so use the point 4, 1, plug them in, solve for b. That's -1. So now you have a slope and a y-intercept. You can write an equation of the line. Y equals 1/2x minus 1 is your parallel line that goes through point P, and it's parallel to line L. Okay, what about the equation of the line through P that's perpendicular to L? So we want the same point, but it's going to be on the line that's perpendicular to line L. And so how do you find a slope that is perpendicular to 1/2? Well, you need to think the product has to be -1, right? So first of all, you need to make a product that it's 1. You multiply by 1/2 and it becomes 1, but then it's negative, right? So first of all, you have a slope that's 1/2. 1/2 times something has to be -1, right? Because 1/2 is positive, you need to have a negative number to make it a -1. How do you make 1/2 become 1 by multiplying a number? The reciprocal. So for any perpendicular line, you're going to find the slope that is the opposite reciprocal of the original line. So the opposite reciprocal of 1/2 is -2/1, which is just 2. Okay, so 1/2 times -2 will be -1. That is your opposite reciprocal. Opposite reciprocal. So step 2, solve for the y-intercept is the same. You plug in the point into your equation, y equals -2x plus b. Okay, plug in 4 for x and 1 for y, because that is your coordinate point. Okay, your y-intercept is 9. The equation of the line is y equals -2x plus 9. So that is the line perpendicular to L passing through the point. This is the point that is parallel to line L that passes through point P. Okay, let's try number 4. What are the equations of lines parallel or perpendicular to the given line K passing through point T? So you need to write both parallel and perpendicular line for both A and B that goes through point T. Okay, first of all, parallel lines should be the same slope. So you're gonna have y equals -3x plus b, and you plug in your point for x and y. And solve for b. Okay, 1 plus 9 is equal to b, which is 10. So parallel line for a is going to be y equals negative 3x plus 10. Same thing for perpendicular line, except your slope is not going to be negative 3. What is it going to be? What's the opposite reciprocal of negative 3? Positive 1 over 3. Yes, so do the same thing with a different slope. Okay, plug in the numbers again. All right, so the perpendicular line for part equation A, in part A would be y equals 1 over 3x plus 0, which is y equals 1 over 3x. Okay. What about part B? Do the same thing. Parallel.
Good morning, WYIS.
All right. So the slope for the second one is 3 over 4. And that's going to be y equals 3 over 4x plus a different y-intercept, right? Because you have a different point. So plug in 12 comma negative 2 into this equation. When you plug in 12 for x, you should get negative 2 as a y, and you're solving for your y-intercept. That makes this true. Okay, so let's simplify it. Let's first multiply the slope and this x, and so you get 9 plus b equals negative 2, and your b is going to be negative 2 minus 9, which is negative 11. So parallel line to your second equation that goes through point T is going to be y equals 3 over 4x minus 11. Okay, and perpendicular, your opposite reciprocal of 3 over 4 is negative 4 over 3. Opposite sign and the reciprocal, right? So y is equal to negative 4 over 3x plus b, and plug in your points again and solve for them. Make sure you don't mix up your x values and y values, okay? That is your x and that is your y in your coordinate point. All right, and you have negative 2 is equal to negative 16 plus b. And do not confuse b as 6. I've seen some people do that. B is b, and it's your y-intercept. Okay, so b is going to be negative 2 plus 16, which is 14. So perpendicular line would be y equals negative 4 over 3x plus 14. Okay. All right, so in summary, what did we learn today? Slopes of parallel and perpendicular lines. There was a lot of algebra in this lesson. So for parallel lines, you know that the slopes are the same. And for perpendicular lines, you know that the product of the two slopes is negative 1, which means the slopes are the opposite reciprocals. Okay. All right. That was lesson 2-4. Bye.